We've been talking about matter, and matter has two components, mass and volume. You cannot talk about matter without talking about atoms, because atoms also have mass and volume. They're the basic unit of matter for the universe, so we're going to talk about them. Atoms have two regions. They have a central nucleus, and surrounding that nucleus is their electron cloud. So let's talk about that nucleus. The nucleus is where all of the mass of that atom comes from. The nucleus is composed of two different parts. There are two different types of subatomic particles. Subatomic means below atomic. So two types of subatomic particles that make up the nucleus, and those are protons and neutrons. Each of those have mass, and scientists have done a very good job making the math very simple for us. Scientists have defined atomic mass units. So when we're talking about the mass of an atom, we're talking about atomic mass units, aka AMUs. A proton has one atomic mass unit, and a neutron has one atomic mass unit. So when you're trying to find the mass of an atom, all you do is add up your protons and neutrons. Carbon has 6 protons, and if it has 6 neutrons, you put them together. 6 plus 6 is 12, so the mass of carbon is 12. Very simple. Just add up the protons and neutrons. Now, there's some more details about protons and neutrons. Protons are positively charged, which means that they act like magnets. They are attracted to negative charges, and they repel other positive charges. And another very significant thing about protons is that they determine which element you have. If an atom has 8 protons, it is always oxygen. And if an atom has 3 protons, it is always lithium. And if an atom has 79 protons, it is always gold. And that determines the properties of the atom. So gold is shiny, kind of yellow, it's bendable, it can conduct electricity, it's a metal. So all of these qualities about gold come from the fact that it has 79 protons. So the protons determine the identity and the properties of the atom. Very important job. Neutrons also have an important job, and that's because protons are positively charged. So they're, all these positively charged particles in the nucleus, they're trying to get away from each other because like charges repel. So the neutrons are the peacekeepers. They are like keeping everybody held together. They're saying, hey, neutrons, don't leave. We're a fine, happy atom right here. Don't go anywhere. We want you to stay. And that's important that neutrons do that. They kind of put space between the protons so that the repulsive force isn't so active, isn't so strong. So thanks, neutrons, because without you, we wouldn't have atoms. The protons would go shooting everywhere. We wouldn't have matter, we wouldn't have stuff, we wouldn't have the basic matter of the universe. So, good job, neutrons. So, the second region is the electron cloud, and that surrounds the nucleus. And in the electron cloud, we find another subatomic particle, electrons. Electrons are negatively charged, and they are always moving. So, they are attracted to the nucleus, because as they have negative charges, and the nucleus has protons which have positive charge, they want to get as close to that nucleus as possible. They're kind of like moths surrounding a light bulb. They come in and they flitter about, but they are so much faster and they never stop moving. So they're really zigzagging really quite wildly around that nucleus. And if the nucleus has more positive charges, then more electrons can be attracted. And those electrons don't hang out near each other because they have negative charges, and so they're always repelling each other. And so you kind of have this dance that they do where they're avoiding each other around the nucleus. And as more electrons come to be attracted to that nucleus, they kind of get in each other's way. So in the first sort of really close area around the nucleus, although it's not really that close, it's relatively close, but it's not really that close, you can kind of fit 2 electrons that are like really close, but when a third one comes, it can't really elbow its way in because every time it tries to get close, it gets repelled by the negative charges of the other electrons. So then it's kind of hanging out in an area outside of that closer area. And more electrons can be attracted to that area, but then it kind of fills up, and then we have to go even farther. And so we have these sort of layers of electrons, and we call those layers in the electron cloud shells. So there are rules about how many electrons can be in each shell, and we'll go over those later. But for now, know that electrons are always moving, they're negatively charged, and they're trying to get as close to that nucleus as they can, but they kind of get in each other's way, and so they end up organizing in layers. We'll talk about those later. I hope this helps. Struggle well.